So, today, we're diving into the world of robotics. And no, we're not just going to talk about the wild stuff you see in sci-fi movies. We're going to look at the real mission behind these machines and how engineers are quite literally designing our future.
Okay, quick question. When you hear the word robot, what pops into your head? Some kind of metal butler? A super intelligent machine from a movie? Whatever it is, just hold that thought. Because for the people who actually build robots, it doesn't start with a cool gadget. It starts with a problem.
Exactly. Because where most of us see a futuristic gizmo, engineers see a solution. They see a tool that can make the world a little bit better, a little bit easier, and definitely a lot safer. And that sense of purpose, that's the blueprint for everything that comes next.
So what is that big promise anyway? What's the core mission that's really driving this whole field forward?
For a lot of people in this field, the main mission is, well, it's deeply human. It really starts with this simple, compassionate goal to help out, to give support and independence to people who need it most. And let's be real, in a world where populations are getting older, this isn't just a nice thought. It's a critical challenge. The goal was never to replace us, but to empower us. All right, so that's the why, but what about the how? I mean, what does it actually take to bring a robot to life? Let's pop open the Builder's Toolkit and take a look. It all starts right here with the robot engineer. But this isn't just one single job. It's more like 3 jobs all mashed into one. You have to be the architect who designs the whole thing, the builder who actually puts it together, and the pilot who controls it. All of that, all at once. And to do all of that, you need this really powerful mix of skills. Science, of course, that explains how the world actually works. Then you have maths, which gives you the precise language you need to figure out movement and logic. And then there's coding. That's the secret sauce that brings the machine to life, turning it from just a lump of parts into a smart machine. Okay, so an engineer can build the body and code the brain, but how does that robot actually interact with anything? How does it get information from the world around it into its digital mind? The answer is actually pretty straightforward. Robots use sensors pretty much the same way we use our senses. A camera acts like an eye, a microphone becomes an ear, and touch sensors can feel pressure. In a way, engineers are just creating high-tech versions of our own biology. And here's how that works in the real world. A robot doesn't see a rock the same way you or I do. Instead, its camera sensor just collects raw data, patterns of light and shade. Then the code in its brain analyzes that data and makes a call. Yep, this pattern matches the rock I was programmed to find. It's a clear process. You get the information, you interpret it, and then you act on it. Now that we get the basic blueprint, let's zoom out. Where are these smart machines already showing up in our world right now? The truth is, they're becoming part of our daily lives. You might even have one of those little robot vacuums cleaning your floors. But if you look closer in our cities, you'll see they're being developed for everything from collecting trash to helping out in hospitals, taking care of logistics so doctors and nurses can focus completely on their patients. Transportation is another massive area. A robot-assisted car uses sensors to see the road, and its computer brain can make decisions way faster than any human ever could. It has one single, unbreakable focus, keeping the people inside and outside the car safe. And the reach of robotics goes way beyond Earth. We send robots out as our scouts, our proxies, to explore places that are way too dangerous or far away for humans, like the surface of Mars. They basically become our eyes and hands millions of miles away, gathering data and beaming it all back home to us. But this might be the most incredible application yet. We've gone from robots that assist us to robots that can actually create parts of us. With microscopic precision, some medical robots can now build an artificial ear, a device that can help a patient hear again. That original mission we talked about, helping people, this is it, becoming a reality in the most amazing way. Thinking about that just naturally leads us to our final and maybe most important question. After seeing all this, we've got to ask, what comes next? Let's just sit with that for a second. If our machines have gotten so advanced that they can construct a part of a human body, what does that say about the future we're all building, right at this very moment? It all circles back to this idea. None of this is happening by accident. It's a conscious, deliberate choice. It's the process of designing smart machines. We're the architects, and we're intentionally building tools with more and more intelligence and capability. And that leaves us with the biggest question of all.
As we design these smarter machines, making them extensions of our own abilities, how are they, in turn, redesigning us? How is this process changing the way we live, the way we work, and the way we connect with each other? It's something to think about. Thanks for joining me.